You've also done a lot of work just on increased incidence of extreme storms around the world related to climate change. Have you refined that any further? Is there more to say on that? Do we know anything that we didn't know 2 years ago?
Well, we've seen from other groups, really interesting analyses of the historical record, and there's been a big barrier, and with severe thunderstorms in particular, in terms of the observed record, and the fact that our observing system has not been as developed as it has been, say, for surface temperature or for precipitation, for that matter. And we've seen some very important papers come out in the last couple of years, finding clever ways to extract information from that observed record, credible information, and identifying some trends in the risk of different kinds of storm characteristics, including the risk of large so-called outbreaks of severe tornado outbreaks, for example, associated with severe storms. So I think we're seeing some really interesting work in the observed record. I think in terms of the what's available with the climate model analysis, we published in 2013 the analysis of the CMIP5 GCMs, arguing that in this sort of wrestling match between increased convective available potential energy and decreased wind shear, that really in the climate models there's a robust result of the increased CAPE winning over the decreased wind shear, and that really came in terms of the climate model results, because the decreases in wind shear were happening on low CAPE days, and so the overall robust signal was towards greater occurrence of the combination of high CAPE and sufficient shear. I think really the next frontier on that work is more explicitly resolving the processes that create storms. I think we've not. I think that there's less available space to really improve our understanding using the low resolution global scale climate models, and really the question is, can we get down to the scales at which the storms really occur, and will we get a different result when we're resolving those processes?
Okay, when you say CAPE, you are referring to.
So CAPE is convective available potential energy. Essentially, it's a measure of the energy that's available in the atmosphere for convection.
Right, right. So my understanding from people who look at things like tornadoes, for instance, is that we don't really have a long enough record using the types of measurements that we do now to really tell us what we're seeing in terms of more tornadoes, less tornadoes, more strong tornadoes. How?
Yeah, Harold Brooks and Michael Tippett and his colleagues at Columbia, and Jim Melsner, and his colleagues, they've all independently have had important new studies published in the last couple of years analyzing the historical record. And I think that certainly when we wrote our perspective piece, Jeff Trapp and Harold Brooks and I in 2008. We did, at that point, our view was very clearly that the observed record was just insufficient for doing that kind of historical detection. And I think we've seen some big innovations in the last couple of years that have kind of put that observed analysis on the table. And I think that's really important progress. Well, no, the work that we've done has been analyzing climate models and the response to increasing greenhouse forcing. And where we really see the robust signal in the climate models is out around the 2-degree Celsius level of global warming, is where we really see all the models agree on increasing occurrence of atmospheric environments that tend to be conducive to these kinds of severe storms. So that's what I can speak to.